Okay, confidence intervals. We have left confidence intervals, tests for one sample, and we have confidence intervals and tests for two samples, and we have chi-squareds left. Today we're going to do confidence intervals, one sample. Friday we're going to do tests for one sample. Tuesday we're doing confidence intervals and tests for two samples. Thursday we're doing chi-squared. Then I have you Monday and Wednesday. Yes, I can teach you Wednesday. So I'll have you two classes after that. And when's our review session after school? Monday before your test, 3:45, the day after Mother's Day. Okay, whose birthday? Yours? We'll have big cake for you. Okay, y'all ready? 20 minutes. Here we go. Intervals. Sometimes the book will say estimate. You're giving an interval. Isn't that an estimation? It's in here. So if you see the word estimate, it means an interval. We were going to break this down to proportions and means. The biggest thing I want you to remember is that Z's are proportions and T's are means. And that was the number one mistake on your multiple choice on this test, was I would give you a mean and you would use a Z instead of a T. So that's super, super important. This is called your margin of error, and I want this to make sense. This is not on your formula sheet. Take your formula sheet and flip it over and look at the top back. Do you see the words confidence interval? That is where you live for this chapter, right there. Oh my God, I don't know what to do. You go look at that formula sheet right there where it says confidence interval. Your margin of error is what you're adding and subtracting. It says statistic plus or minus and then a whole bunch of stuff, right? Your critical value times your standard deviation. This is your margin of error. It's your wiggle room. Make sense? So your margin of error is the critical value and the standard deviation. That's important. I'm going to say that one more time. Your margin of error is your critical value and your standard deviation, because that's going to come into play here when we find your sample size. Standard error is just your standard deviation. Okay, standard error is just your standard deviation. What's your margin of error? Critical value times the standard deviation. Finding a sample size. You don't need to memorize this formula, but you need to memorize where it is on the unit circle and which part you're going to use. So this is your margin of error. See ME? Who? Huh? Oh God, did I really? What did I mean to say? Formula sheet? Formula sheet. On your formula sheet. Sorry. On your formula sheet, it's your critical value times your standard deviation. It's going to say, and we're going to do a problem like this. You're going to do them in your homework. It's going to give you the margin of error. Find the sample size that would have a margin of error less than 0.03. So you're going to set this up. 0.03 is going to go right there. You're going to have your less than or equal to. You're going to find your critical value and your standard deviation. You're going to solve for n because you're looking for your sample size. You don't ever round down. You always round up. Do y'all remember that? It says it on here. Always round up to the nearest whole number. Okay, same thing for means, but I want you to look here. That's not a typo. That's not a typo. That is a Z, not a T. So in your brain right now, you need to commit to memory that for sample sizes, it's Z's for everybody. For sample sizes, it's Z's for everybody. Because if I want the sample size, I know the mean and the standard deviation of my population. Go way down here to the bottom. Read that little bullet right there to yourself. The only reason we use a t-distribution is when you don't know the population standard deviation. And it makes sense to use that when we're estimating means, because if we knew the mean, number one, we wouldn't be estimating it. And if we don't know the mean, we don't know the standard deviation. Doesn't that make sense? Is that logical? So let that help you remember it. Okay, your steps for a confidence interval. Tell me what it is. A one sample t interval. This is not a test. Why is this not a test? There's no hypothesis. This is an interval. This is an estimation. It's a one sample for today, z interval, or a one sample t interval. Z intervals are for who? Proportions. T samples are for, okay, one more time. Z intervals are for proportions. Z's are for proportions. T's are for means. Define your parameter. Parameter is the mothership, P, not P hat, P, and mu, the true proportion of all, remember that word all I made such a big deal about? The true proportion of all people who are going to the baseball game, or the true mean GPA of all students at South Stokes High School. Conditions. Now, this is from after you took your test. I came in here and underlined this to remind me that this is what y'all screwed up on. So I need to do a better job stressing this next year. If I'm a proportion, do I worry about being normal? No. Normal is only for what? Means. So I need to be random. I need to be independent. Why? Why do I need to be independent? What does this give me the green light to do? Find your standard deviation. The law of large counts gives you the green light to find your standard deviation. I think, no, doesn't say it down there. And the large counts condition, NP and NQ have to be bigger than 10. Guys, honestly, some books instead of 10 use 5. If you see a multiple choice question, you're going to see a multiple choice question tonight that says NP and NQ have to be bigger than 5. That's not them trying to trick you. That's just some books set the bar at 5. Ours set it at 10. If it's a free response, you go with 10. But if it's a multiple choice and they use 5, go with it. It's okay. You with me? Everybody okay? Normal. If your sample size is bigger than 30, normal. And you say why. If it's not bigger than 30 and it doesn't tell you that it's normal, what must you do? You got to graph it, which means they have to give you individual pieces of data, which means you put them into your L1. And then what do? So you go stat plot, you turn it on, you go to a box and whisker that has the outlier dots. Remember, there are 2 box and whiskers there, and you want the one that has the outliers. And then you go zoom 9 for stat. And it'll show you, and you draw it. And guys, don't you draw this random box and whisker. You draw what you see so they can tell that you actually drew it. And what are you looking for? No strong skew. It can be a little skewed, but no strong skewness. And no outliers. That's a have to. That's a black and white. Okay. Now, it says step 4, find critical value. My brain doesn't go there. After I do all this, I sort of have this panic. Oh, God, where do I go next? Go here. Go to your formula. Go to your formula sheet. You're finding a confidence interval. It's labeled on your formula sheet, confidence interval. And you're going to start with this. Well, statistic, if it's a P, that's your P hat. Critical value is your Z star. Where do you get him? Yes, that's your, oh yeah, I got to go find my critical value. So you go over here to the side, you draw your graph, because it's going to say I want a 95% confidence interval. So you do this, you put 95. And for Z's, you do what? You inverse norm. Percent to the left, which here would be what? 0.025. 0.1, you get your plus or minus Z. So he goes there. You got your P hat and your Q hat from the problem, and you have your sample size. And remember, you type the -1 in first because that gives you your smaller number. And then you go back and change the minus to a plus, and you get your bigger number. No, okay, because you're looking at me strange. Then you say we are 95% confident that our interval from here to here captures the true proportion of all people who are going to the baseball game. If it's a mean, you go here. Statistic is going to be an X bar because we're talking about means. My T star, which is my critical value, I'm going to draw my graph percent to the left. I just inverse T percent to the left. Who is he? So you're going to come over here and you're going to go N minus 1 because they love for you to make a big deal about degrees of freedom. And then you're going to go degrees of freedom is, I don't know, 10 minus 1. And then you're going to have a 9 right there. And it's going to make them super happy because you're defining what all this stuff is. You don't have to, but boy, I think it would make them happy. Remember I even said you could write thicker tails because it's a T distribution. Y'all remember that? I gave you little smiley faces if you did that. And then my standard deviation of my statistic. Now, how are you going to remember this part? Flip your formula sheet over. Find him. Do you see your standard deviation for proportions? Do you see him? Do you see your standard deviation for means? That's the one we screwed up 3 times on our homework today. So this is not a, oh my God, I've got to, you just have to know what it is and where to find it on your formula sheet. All that stuff is there. And then you write your sentence. Everybody good? Large counts conditions. This just says that some use 5. Might show up in a multiple choice question like that. It is going to show up on this homework. I don't know what the AP people are going to use. And I also wanted to point out the bigger your sample size is, the smaller your standard deviation. We talked about that a little bit. What is that going to do to my interval? Does it make your interval smaller? Is it a smaller amount of area? No, it just makes it narrower because the graph gets taller because your standard deviation is coming in. So it makes your confidence interval narrower. That's on, I did this after I did the homework. I added these 3 dots on here. Okay. Grab your Chapter 8 test. Let's see. I think we should do a free response first so you can see one start to finish. And then if we have time, we can go over some of the multiple choice. Now, you can't take the test, but what do you have? You have a Chapter 8 test review, don't you? That looks almost identical. Okay? All right, let's look at number 15. It says, a local newspaper in a large city wants to assess support for the construction of a highway bypass around a central business district to reduce downtown traffic. They survey a random sample of 1152 city residents and found that 543 of them support the bypass. Can everybody see that this is a proportion and not a mean? It's this many people out of this many people. So I already know it's a one sample Z interval. Why Z? Because this is a proportion. Name your test. What is it that I'm doing before you dive in? Then I'm going to define my variables. Don't these in your brain kind of go hand in hand? State what I'm doing, define my variables. State what I'm doing, define my variables. The true proportion of all city residents who support the bypass. Everybody good there? This is me just doing what I do for me because it just helps me. Conditions, random. It says that it's a random sample. Independent. Now, what are we assuming here? That there are 11,520 residents in this city. That's what I'm assuming. And if you want to write that off to the side, that's just awesome. If you want to write that. Because I don't know if this is true. This could be a tiny city. Okay. Well, definitions of largest can vary. Anyway, large counts conditions in P and NQ have to be bigger than 10. I'm not looking for normal. Right? NP and NQ have to be bigger than 10. Then I go here. I put my words, remember? Words, letters, numbers. Words, letters, numbers. Here's him. Then I'm like, oh yeah, I got to go find him. So I came up here and I did this and I did this, but you're going to do this. Percent left, mu, so yeah, mu sigma. And you're going to get him. So he goes there. Who is that? That's him, just as a decimal. And then that's 1 minus that. There's my sample size. I do the plus version, I get that. I do the minus version, I get that. And then I write my beautiful sentence. Everybody good? Next problem. Number 16, there are many ways to measure the reading ability of children. Research designed to improve the reading performance is dependent on good measures of the outcome. One frequently used test is the DRP. A researcher suspects that the mean score, so your brain goes, what? I'm means and I'm T's. So let's see, I'm a one sample T interval. One sample T interval. This can change to 2, this can change to a Z, and that could change to a test. Do you see how you have to make a decision on every single word? Mu, parameter, the true mean score of the DRP test in Henrico County Schools for all third graders. I think this was something that a lot of people left off. Is that right? Because we're just talking about third graders. This is me just writing out all my information. Conditions, random, yes. Independent, what are we assuming? There are at least 440 third grade students in this county. Normal. Central limit theorem applies because my sample size is bigger than 30. Now, when do I do normal and when do I do NPs and NQs? Normal is for means. NPs and NQs are for, does that make sense? NPs and NQs is when you do P's, right? If you do this on a proportion, you will lose massive points, not little points, massive points. So then I go to my formula, because after I do my conditions, I have this, holy crap, what do? So then you go to your formula sheet and I get my words. I fill in with my letters. Statistic here is X bar. Critical value is a T star. And there's my standard deviation. That's the one that bit you on the butt like 3 times today, right? We're good friends with him now. Then I've got the data. Oh, and how did I get my data? Mean, standard deviation. It gave me a sample size. Okay. So there's my mean. There's my T, so I have to go find my T. So I go over here, 90% inverse T. Now what did I not do? There you go. And percent left degrees of freedom. Y'all going to make that all beautiful, right? And you're going to practice that on this homework. There's my standard deviation over my sample size. There's my beautiful sentence. Everybody good there? Use the confidence, and this is a fantastic follow-up questions that are pains in the butts. Use the confidence interval you constructed to comment on whether you agree with the researcher's claim. Explain your reasoning clearly. I didn't read the question that good. National mean score of 32 is not in our 90% confidence interval, which confirms the researcher's suspicion that the third graders in this county are different than the national mean. So it's saying to test her suspicion. Her suspicion is a researcher, I had to find it. A researcher suspects that the mean score is different from the national mean, which is 32. And we agree because, look at our interval. Not only is it not in that interval, but it's a little, you could do a whole separate test for Part B if you wanted to. But first you have to find what the average is. This is the level of dissolved oxygen in a river for the fish. Everybody remember that? Construct a 95% confidence interval. So this is a one sample T interval because these are what? Averages. I defined my mu. I typed my data in and got this. Right? L1, one variable stats. My conditions, he is not central limit theorem. Because I only have 15 samples, so look what I did. Oh, was it provided for you? Okay. And I didn't write no outliers and no strong skewness. And then I've got off my formula sheet, my letters, my numbers, my inverse T, and my sentence. Are you back in the groove of this? Do you have the gist? Okay. I'm not going to have time to go over any of the multiple choice. The multiple choice are really good. I strongly recommend that you take time to go over your Chapter 8 review. Put this test back in the folder. Pass your folders up. Everybody's got your homework. Everybody's clear on what you're doing. You are doing the Prentice book, page 321, number 3, number 5, number 8, and 10A. And you are doing the worksheet that I gave you.